So here's the review for Unit 1. Alright, first part is factor each of the following. Well, you notice there's only two terms. So you're not going to try using the Rosso method when you have two terms. You're just factoring out the greatest common factor. 40 and 32 are both multiples of 8, so I can factor out an 8. And you notice they both have at least one a, factor out that a. 40 divided by 8 gives me 5. There was two a's here. I took one. There's one left. Minus 32 divided by 8 is 4. There was one a there. I already took it, so you're done. 51c to the third minus 34c. Again, only two terms. You're not using the Rosso method. Alright? So 51 and 34 are both multiples of 17. Again, c to the third and c. I can factor out at least one c. So I'm left with 3c squared minus 2. I can't do anything in here inside the parentheses. It's not a difference of two squares, so I can't do anything, so you're done. 3x squared minus 12. I can factor out a 3 only because you notice there is no x over there. There is no x, so I cannot factor out an x. I'm left with x squared. 12 divided by 3 gives me 4. And this is the difference of two squares. So square root of x squared is x. The square root of 4 is 2. So my final answer, x plus 2, x minus 2. Alright, number 4. You look at all these things. 8, 4, and 12. They are all multiples of 4. X squared, x to the first, no x's. Means I cannot factor out an x. But they all have z squared in there. So I can factor out a z squared. Alright, what am I left with? 8 divided by 4 gives me 2. I did not factor out x, so I have x squared. And then minus 4 divided by 4 gives me 1. I took out the z squareds already, so I'm left with just x. Minus 12 divided by 4 gives me 3. There was no x's there. Alright, now, using the Rosso method, can I do anything? Can I factor this thing? So remember, the Rosso method, because it's a trinomial, alright, a trinomial, meaning there's three terms. Alright, there are three terms there. Sorry, I'm trying to erase other stuff. Alright, there's three terms. So I can use the Rosso method. And then, what was the pattern? I look at the second sign. Second sign, the second sign being negative tells me these signs are the same. Different, excuse me. They're different. 2 times 3 gives me 6. Factors 1 and 6. 2 times 3. Alright? 3 minus 2 will give me this 1 that's sitting right there. Alright? There's that 1 that's sitting right there. Alright, so then, the other part to the Rosso method was the bigger number of that pair takes whatever sign that is. So that 3 has to go there because those are both negative signs. 2 goes over there, and I have to divide by whatever this leading number is. So I have to divide by 2. Alright? I don't do anything with this other than rewrite it. Now I look at that right there. 2x, 2, and 2. They are all multiples. They are all multiples of 2. So I can factor out a 2 from everything. Or divide out, however you want to say it. X plus 1. 2 divided by 2, 1. Remember I said in class, 1 and done. So now I just bring that other factor down, and you're done. Alright, number 5. Number 5, they are all multiples of 6. So I could factor out the 6. And again, this one, they all have a y squared. So I'm going to factor out the y squared. What am I left with? 2x squared minus 3x plus 4. Alright, again, simply bring that 6y squared. Whatever that greatest common factor was out in front, you just keep writing it. Alright, don't worry about it. So now I want to do 2x. Remember the Rosa method. Alright? Whatever this thing is, you write it down 2 times. And then you're going to divide by, oh, it's not showing up. Alright, it's not going to, we're going to divide by whatever that leading coefficient is. So I'm dividing by the 2. In this case, the plus there tells me the signs are exactly the same. So I have to move to the first sign. Tells me they're both going to be negative. Alright. 2 times 4 gives me 8. And factors of 8, 1 and 8, 2 and 4. Well, neither one of these factors, neither one of those pairs are going to give me 3. 1 plus 8 gives me 9. 8 minus 1 gives me 7. 2 plus 4 gives me 6. 4 minus 2 gives me 2. Nothing is going to give me that that 3. I don't care about the negative. Nothing's going to give me that 3. So I cannot factor this thing any further. So I'm done right here. Alright, I'm done right there. I'm just rewriting it to make it look a little nicer. Because it cannot be factored any further. You're done. I checked it. Doesn't work. Alright, number 6. Find the dimensions. So I have to figure out what x is. Well, length times width. Alright, length times width will give me the area of this rectangle. So x plus 2 times x minus 2 equals 96. FOIL, double distributive property, whatever you want to call it. X times x, x squared, x times negative 2, negative 2x, and then distributing that 2 to both of those, positive 2x, and then negative 4, and it still equals 96. Well, you'll notice those cancel each other out. I'm left with x squared minus 4 is equal to 96. Alright, right here at this step, there's 2 approaches we can take. One of them is I can add 4 to both sides, so I have x squared is equal to 100. Then take the square root of both sides. X is equal to plus or minus 10. Or the other step we could have taken is I could have subtracted 96 from both sides. X squared minus 100 is equal to 0. And you notice it is not 3 terms, so I'm not going to try factoring it. I could use the quadratic formula if I wanted to. In this case, if I use the quadratic formula, b is 0, a would be 1, c would be negative 100. But in that case, you're doing way too much work. Alright? The easiest was the first approach. Here's the second approach. This one, hopefully you recognize it's the difference of 2 squares. So, square root of x squared is x, plus minus, square root of 100, we already talked about, was 10. Now you solve both of these things. So here, x is equal to negative 10, x is equal to positive 10. Alright? Same answers. Same answers. I don't care what method you use, whichever one you're more comfortable with. Alright. In this case, I needed to force it to equal 0. Alright? So number 7, I have to force it to equal 0. So I can subtract 5 from both sides. 12x squared minus 4x. These are not like terms. Do not combine them. They are not like terms. Alright? Don't do that, please. 12, 4, and negative 5. I cannot factor anything out. So, I have a choice. I can either try factoring it using the Rosa method because there's three terms, or I can just jump right to the quadratic formula. Well, I'm going to try to see if I can factor it. Right? I'm going to try to see if I can factor it, simply because it's a little bit less work. Alright, so here's the little trick I do. Before I even write any of the Rosa method down, 12 times 5 gives me 60. Gives me 60. Now, I could, let me rewrite it up here a little bit higher. Gives me 60. I could go through and do 1 times 60, 2 times 30, 3 times 20. Alright, you could go through all those. Hopefully at this point you're starting to look a little bit ahead and you're saying, I need to get a 4 there. I need that middle term to be 4. So then you say 6 times 10. 10 minus 6 will give me 4. Alright? 10 minus 6. Sorry, that's supposed to be an arrow. 10 minus 6 gives me 4, which is what I have there. Alright, so now I will go through the Rosa method. The pattern, 12x. 12x all over 12. Second sign being negative tells me signs are different. Again, the bigger number, which is 10, the bigger number, which is 10 right there, has to take that first sign. So I have to put the 10 there, 6 goes there. Now, think about that. What number goes into all three of those? I can divide all three of those by 6. So, because I'm running out of room, I'm going to write up here. 12 divided by 6 gives me 2x. 6 divided by 6 is 1. 12 divided by 6 is 2. I rewrite the 2 on that side. Now I look at those three. What goes in all three of those? 2 goes in all three of those. So I'm left with 6x minus 5. 2 divided by 2, 1. 1 and done. Alright? Now, I need to solve here. Okay? Because it told me I had to solve. I can't just stop there. It didn't tell me just a factor. It told me to solve. So x is equal to, subtract 1 from both sides, divide by 2. I have negative 1 over 2. Sorry. Negative 1 over 2. In this case, I'm going to add 5, divide by 6. X is equal to positive 5 over 6. Alright. Hopefully you guys are okay with this. Alright, over here, I'm going to add 48 to both sides. So I have 16x squared plus 48x plus 36 is equal to 0. And I noticed they are all multiples of 4. Now, in the past, I kept telling you just write the 4 on the outside and don't worry about it, leave it alone. Well, I'm going to show you really what's happening here. So I'm left with 4x squared, plus 48 divided by 4 gives me 12x, 36 divided by 4 gives me 9. Now, in the past, I told you just keep rewriting it each time and then set it equal to 0, 4 equals 0. Okay, hopefully you remembered that. And I said, oh, 4 does not equal 0, so that's a garbage answer. Alright, here's what's really happening, is we're going to divide both sides by 4. So I'm left with 4x squared plus 12x plus 9 is still equal to 0. Right? That divides out. It's still equal to 0. Now, we look at this, and you have a choice. Are you going to factor, or are you going to use the quadratic formula? Okay? You have to make that choice. Do you want to factor or use the quadratic formula? Well, again, 4 times 9 gives me 36. And if I do a little bit of thinking, 1 times 36, 2 times whatever that is, 18, alright? Eventually you get down to 6 times 6. 6 plus 6 will give me that 12. Alright, so I'm just going to factor it. 4x times 4, not times, excuse me, just using the pattern, all over 4. Second sign being positive tells me the signs are exactly the same. I look at that, it tells me they're both going to be plus. Alright, now 4 times, so we already said it was going to be 6 and 6. Well, Rosa method tells us, look at those 3. 4, 6, and 4. I can divide all those by 2. So I'm left with 2x plus 3. 4 divided by 2, 2. Come over here. They're all divisible by 2. Same exact factor. Alright. So again, 2 divided by 2, 1. 1 and done. Alright, solve. X is equal to, subtract 3, divide by 2, negative 3 over 2. And this one's going to be exactly the same. Alright, not going to waste the time. Number 9. Well, first thing I notice, there's no x term. There's an x squared, but there's no x term. So I can add 200 to both sides and then try to factor, right? But it's telling me to solve. So I think the easiest thing to do, in my opinion, is I'm just going to subtract 45 from both sides. So I have x squared is equal to negative 245. Alright? And I take the square root of both sides. I notice there's a negative underneath the radical. As soon as I notice that negative underneath the radical, I know I'm going to deal with some type of imaginary number. Alright? So I have to remember there's an I there. Well, grabbed my calculator because I have no idea. Alright, here's my little cheap calculator from the computer. I started doing 245, I don't care about the negative, divided by. And I just started picking numbers at random. Perfect squares. So 3 squared is 9. Alright, so divided by 9. You notice 27 point, I got a decimal, I don't care. So 245 divided by, and I just said, alright, well, let's see what happens to 16. Nothing. Alright, 245 divided by, and then I end up getting up to 49. 7 squared. Alright, so 245 is 49 times 5. 49 times 5 is 245. So I have the square root of 49 times 5, and then I still have that little negative 1 hanging around. So my answer, plus or minus, square root of 49, 7. Square root of negative 1 is imaginary, times the square root of 5. And we're done. Alright, these are those problems I was trying to show you guys in class. Alright, number 10. I see x squared. I see x. Now I have to make it equal 0. Alright, so I'm going to add 17. So I have 12x squared plus 9x. Add 17 plus 15 equals 0. They are all multiples of 3. So again, I could just divide everything by 3. So what am I left with? 4x squared plus 3x plus 5 is equal to 0. Right? Only because it's an equal sign can I divide both sides. If there were no equal sign, alright, if that equal sign was not there, let's say this was the problem. Let's say that was a problem. You could not divide by 3. Alright? You could not divide by 3. Only because there's an equal sign can I divide by 3. Alright, so again, do this little trick real fast. Let's see. Can I factor it? 4 times 5 gives me that 20. 1 times 20, 2 times 10, 4 times 5. Before I even start writing all that stuff at Rosa method, will any of these give me 3? No. Alright? So using the Rosa method is not going to work. So in this case, A is equal to 4, B equals 3, C equals 5. Alright. Here's the quadratic formula. X equals negative B plus or minus the square root b squared minus 4ac, all divided by 2a. All of it, not just the radical part, everything. Alright, start plugging stuff in. X is equal to -3 plus or minus the square root of 3 squared. You notice I use parentheses when I'm substituting here. Minus 4 times 4 times 5. All over 2 times 4. This is where you guys were struggling. For whatever reason, you were struggling with your calculator work here. Alright, 3 squared, 9, minus 4 times 4, 16. So 16 times 5 equals. Do you notice even with this little cheap calculator on the computer, knowing your order of operations, it can still use it. So it said x is equal to -3 plus or minus the square root of -71 all over 8. Now, 71, I tried a whole bunch of things here, alright? So all I'm worried about is 71 because I know it's going to be imaginary. 71 divided by 2 squared. Nope, didn't work. 71 divided by 3 squared. Nope. 71 divided by 4 squared. Nope. Alright, save the time. Nothing worked. So the final answer is x is equal to -3 plus or minus. I have to get rid of that negative. Alright, I have to get rid of that negative in there. So it's I times the square root of 71 all over 8. Nothing you can do, you're done. Alright, number 11. Subtract 6x, add 8. -4x squared plus 6x plus 20 equals 0. Again, they're all multiples of 2, but even better yet, they're all multiples of -2. Let's get rid of that stupid negative hanging out in front. Alright, so I have positive 2x squared minus 3x minus 10 is equal to 0. You notice all that happened was I changed the signs for all of them. Alright, no big deal. Alright, 2 times 10. Alright, same thing. 2 times 10 gives me 20. Well, I already did it. Don't do extra work. You already did it once. 20. I need to get 3. Well, it didn't work for problem 10. It's certainly not going to work for problem 11. Let's go. I already got the quadratic formula written once. Alright. A is going to be 2. B is going to be -3. C is going to be -10. So, -3 plus or minus the square root of -3 squared. Parentheses, guys. Parentheses. Minus 4 times 2 times -10. All that mess divided by 2 times 2. So x is equal to negative and a negative, +3, plus or minus square root. Again, here's my little cheap calculator. Right, let me get this thing out the way. -3 squared is +9. 4 times 2 is 8. 8 times -10 is -80. And I have this negative sitting out here in front. So -4 times 2 is -8. -8 times a -10 is +80. So plus 80. So we have 89 underneath the radical. Oh, sorry. We have 89. Try to make it look like an 89. Alright, better. All over 4. Well, again, grabbed my calculator. I tried a whole bunch of things, 89 divided by 4, that's 2 squared. Didn't work. 89 divided by 3 squared, which is 9. Didn't work. Alright, not going to waste the time. Nothing worked. It's not there's no negative, so I don't have to worry about imaginaries. I can't do anything. I'm done. Alright, we move on. Graphing the following quadratic equations. Now, I'm not a fan of having pre-printed um, axes like this, okay? But let's see if it'll work. I need the vertex. It's the first thing I need. I need that vertex. This is in standard form because x squared, x, no x's. It's in standard form. So I have to, I know it's in standard form, so I have to find the vertex. I need the x coordinate first. And it's going to be x is equal to negative b over 2a. X is equal to negative 6 over 2 times 1. So x is equal to negative 3. And now I find the y coordinate by simply plugging it in. Y is equal to, do you notice parentheses? Negative 3 squared plus 6 times negative 3 plus 2. Mental math or some calculator work, and we end up with negative 12. Oh, sorry. We end up with negative 7. We end up with negative 7. So my vertex is negative 3 down to negative 7. Alright? There's my vertex. Now, I need to find a few more points. No, I should have left. Here is my line of symmetry. Alright, my line of symmetry. Well, this thing being positive, I know the graph opens up. Alright, so let's create a table. X, Y. Well, what x values am I going to pick? 1 to the left, 1 to the right. 1 to the left is negative 4. 1 to the right is negative 2. Alright? So I plug those in. Calculator work, mental math, whatever. You end up with negative 6. 2 to the right, 2 to the left, we end up with negative 5 and negative 1. Calculator, mental math, you end up with negative 3. So let's plot all these points. So the first point here, negative 4, negative 6. Negative 4, down to negative 6. Same height, one space to the left, one space to the right. Negative 5, 2 spaces to the left, down to negative 3. 2 spaces, I'm going to go over 2 spaces. And there is a horribly drawn graph, but there it is. Okay? Alright, same thing, standard form. X squared, x, no x's. Alright? Now in this case, don't try dividing out by 4. Don't do that. Alright? Do not do that. Just leave it as is. Because if you try dividing the right side by 4, you have to divide the left side by 4. Don't do that. Just leave it. You have your calculators. So I need the x coordinate for the vertex. So x is equal to negative 24 over 4 times, 2 times 4. Alright. So I have x is equal to 24 divided by 8. So I end up with negative 3. Alright, now find the y coordinate. The y coordinate. We have y is equal to 4 times negative 3 squared plus 24 times negative 3 plus 24. Mental math, some calculator work, whatever, I don't care. Y is equal to negative 12. And this is why I'm not a fan of these pre-printed, because now my vertex is negative 3, negative 12. So this means I'm gonna have to change this graph. So if this was me, I would have raised up my x-axis so that I had more negative space, because I know this thing opens up. But since it's pre-printed, we got to deal with this mess. So here is -2, -4. There's -6, -8. Alright, I'm trying to get rid of all this mess. There's -10, -12, and then there's -14. Alright, so down to -12. So 3, so -3 down to, there it is right there. Because I changed the bottom, I need to change the top ones also. 2, 4, 6, 8, 10. Alright, and let's just kind of scratch those out. This is why, again, I'm not a fan of pre-printed graphs. Alright, and then we have our table. Alright, again, here's my line of symmetry, my perfectly straight line. Alright, one to the left, one to the right. Again, -4, -2. Alright, plug that in, we end up with -8. And then 2 to the right, 2 to the left, -5, -1, and we end up with 4. Alright, plot those. -4 down to -8, and then -5 up to +4. And another horribly drawn graph, but you'll notice it is not a V, it is more U-shaped. Alright, this one is not in standard form. This one is in intercept form. 2 parentheses, 2 sets of parentheses, instantly, intercept. Alright, so I know where it's going to cross the x-axis. I don't care about that negative out in front. All that negative tells me is it's going to open down. So remember what I told you guys? Change the signs. X equals -3 and x is equal to +7. So -3 up to, oh, excuse me, it's not the vertex, it's the intercepts. -3, and then, let's see, 2, 3, 4, 5, 6. Alright, there's 7. Alright, now we need to find the middle. Alright, because this is going to be our line of symmetry. Alright, we need to find the middle. So this is going to give us the x-coordinate of our vertex. So x is equal to, and all we do is we add these two numbers together and divide by 2. -3 plus 7 is 4. 4 divided by 2 is 2. So I know somewhere along this line, somewhere along that perfectly straight line that I drew, is x equals 2. Is the line of symmetry. Let's try it one more time. Somewhere along that line is my y coordinate for my vertex. Alright? Y coordinate. Start plugging stuff into the original equation. Start plugging this 2 in. So I have -2 plus 3 times 2 minus 7. Mental math, a little bit of order of operations. We end up with 25. Again, very much dislike pre-printed graphs. I know this thing opens down, but this pre-printed only goes up to 10, which does not help me. So we're going to have to change the scale some. Alright, so since it's going up to 25, let me see, could I go by 2s and get away with it? No, because I'd only get up to 20. What about 3s? Alright, let's see. Yeah, I could get away with it. It's going to be ugly, but I can get away with it. Alright, so it's going by threes. Alright, going by threes there. So, at -2, positive 2 to 25, let's just say it's right there, just above. Okay? And then I need 2 more. So if I picked 1 and 3, I'll get the same exact answer. Gives me 24. Alright, so this one is actually on the line. Right, and another horribly drawn graph. But you guys get the idea. Alright, there you go. They both gave me 24. Alright, last of these graphs. Sorry guys. Vertex form. Vertex because there's only one parenthesis and it's squared. Alright, so I know it's in vertex form. Vertex form tells me it's going to give me the vertex. I don't have to do any work. Change the sign. So the x coordinate of the vertex is 1. The y coordinate, don't change the sign. So change, don't change. 1 and 3. Alright? Up 1, up to 3. This graph is going to open up. Alright? It's going to open up. Here's my line of symmetry. And now, 0 and 1. Right? I need same skill as you used for those other 2 problems. Alright, pick some x's. One's to the left, 1 to the right. Both of these numbers are going to give me the exact same thing. You plug it in for x. Alright, so 0 minus 1. And use order of operations, some mental math, use your calculator. Again, I don't care, but just get the problem right. And then 2 to the left and 2 to the right. And then you're going to end up with 11. Again, graph's not this pre-printed graph. Bytes, alright, bytes the big one, but all I'm doing is plotting my points. And here's 10, so let's pretend 11 is right there somewhere. I hate doing that. Absolutely hate doing this, but you guys get the idea. Okay? Alright, hopefully that helps you guys with reviewing graphs. Rationalizing the denominator. Remember when I told you guys to rationalize the denominator? I cannot have an imaginary in the denominator. Some dead math guy says, so we got to fix it. How do we fix it? By multiplying by the conjugate. -2i. -2i. All I did was change the sign. It was positive, change it to a negative. No big deal. Alright? Distribute. All you're doing. 10 times -2, -20. Bring that I. Negative times a negative. Positive. 7 times 2 gives me 14. I times I squared. All divided by -4 I squared. Now hopefully you'll remember I equals I, right? No big deal. I squared equals -1. Alright, I to the third equaled -I. I to the fourth equaled 1. Alright, so hopefully that helps you. So I have -20i. I squared is -1. Alright, I squared is -1. So I have 14 times -1 all over -4 times -1. -20i minus 14 all over +4. You'll notice they are all multiples of they are all multiples. I'm sorry, I don't know what's going on here with my computer. They are all multiples of 2. Right? So I have negative, so I'm going to divide everything by 2. -10i minus 7 all over 2. And technically it should be written as negative 7 minus 10I all over 2. And we could break it up even further. What is going on here? We could break it up even further and say negative 7 over 2 minus 10 over 2 is 5I. Okay? I could break it up even further that way. Alright, number 17. Number 17. Again, all I'm doing is changing the sign. Alright, change this sign from a positive to a negative. Change that sign right there. So 2 minus 4I all over 2 minus 4I. Distribute. You're multiplying, so that's all you're doing. 10 minus 20I all over. Now here you got double distributive property or FOIL. 2 times 2, 4. 2 times negative 4I, negative 8I. 4I times 2 plus 8I. 4I times negative 4I, negative 16I squared. Now, did you notice that? Alright? Hopefully you noticed that. What's going to happen there is they're always going to cancel each other out. Alright? They're always going to cancel each other out. So I have 10 minus 20I all over 4 minus 16I squared. Well, again, remember I squared. Remember I squared is negative 1. So negative 16 times negative 1, I have 4 plus 16. So I have 10 minus 20I all over 20. Alright? And 10 over 20, I'm separating it, is 1/2 minus 20 over 20 is 1, so I'm left with I. Alright? Times. Again, same drill. Change that sign. So I have 3 plus 2I all over 3 plus 2I. So distribute. 2I times 3, 6I, plus 4I squared, all over. Now remember, the two inner terms are going to cancel, so I'm going to skip that step. If you need to do it for yourself, go ahead, but you know this step, they're going to cancel each other. Alright, so 3 times 3 gives me 9. Negative 2I times positive 2I is minus 4I squared. 6I plus 4 times negative 1 all over. Remember, I squared is negative 1. 9 minus 4 times negative 1. So I have negative 4, because remember the real number has to go in front, plus 6I all over. Well, negative 4 times a negative 1 is positive 4. So 9 plus 4 is 13. Now, last step would be negative 4 over 13 plus 6 over 13I. Alright? These are those problems I was telling you guys, just get your calculators out. Alright, remember I was telling you to do 22 fraction bar 4. Remember, because, let me come up here to these problems up here again. Because there are 1, 2, 3, 4 of those. Alright, and let me maybe rewrite them again. I is equal to I. I squared is equal to negative 1. I to the third is negative I. I to the fourth is positive 1. Well, if you do this, you're going to end up with